Back. Problem 2. Solid of revolution. Find the volume of the solid obtained by rotating the region bounded by the given curves about the specified axis. So the curves are y equals 3x squared, x equals 1, y equals 0, and you want to rotate it about the x-axis. So let's see the picture for it. Y equals 3x squared, x equals 1, and the x-axis. Okay. Y equals 0 is the x-axis. All right. X equals 1 is the vertical line. Y equals 3x squared is part of a parabola. So you want to take this picture and you want to rotate it about the x-axis. So let's take this region between this curve, this line, and this line and rotate it about the x-axis. When we rotate it, we get such a solid. You see, it's a solid, filled in solid. So x equals 1, x-axis, and the curve, you rotate it. Now when you take slices, because you rotated about x-axis, you would take vertical slices, up-down slices, and you get circles there. Width of each cylinder, small cylinder, is delta x. All right. So further, notice this point is 1, 3. Why? Because you see, you are going until x equals 1. When I substitute x equals 1, I get y equals 3. So that's how we obtain that point. Notice, so my solid is supported from 0 to 1. For each x in the interval 0 to 1, the radius of the cross-sectional circle is y coordinate, which is 3x squared. So the thin cylinder here has thickness delta x and base area. So area of a cross-sectional circle is pi times the radius squared, which tells me volume of the solid. It is integral 0 to 1 because my solid is supported on the x-axis from 0 to 1. So integral 0 to 1, cross-sectional area dx. So simplifying this, I get 9x to the power 4 with a pi outside. When I take integral, I have to take x to the 4th. Its integral is x to the 5th over 5. 9 is a constant multiple. Apply the limits of integration, which gets me pi 9 over 5. That is pi times 9 over 5. So don't forget parentheses. Star means multiplication. Okay, so it's correct. Next problem. Find the volume of the solid obtained by rotating the region bounded by the curves y equals square root x minus 1, y equals 0, x equals 2, and x equals 3. So let's figure this out. Okay, so you want y equals square root x. That's this. Square root x minus 1. So you take square root x, shift it right. That is square root x minus 1. Y equals 0 is the x-axis. X equals 2 is a vertical line. X equals 3 is another vertical line. So the region between all these curves is under this curve, between these two lines, and above this line. Okay, so Let's visualize it clearly. Y equals square root x minus 1. Between the lines x equals 2, x equals 3, and y equals 0. Okay, so notice when x is 2, y is square root 2 minus 1, 1. When x is 3, y is square root 3 minus 1, that is square root 2. So you have this point here and this point here as your intersection points for the two sides. Okay. Now further they are saying you rotate it about the x-axis. So you're going to rotate it about the x-axis. You need to take this region, rotate it about the x-axis. When we do that, look at that solid, right? So going from here to here, you have rotated. So notice your cross sections are vertical cross sections because you rotated about the x-axis. Width of each cylinder is delta x, and what happens to the solid? The solid is supported on the x-axis from x equals 2 until x equals 3. Therefore, the interval is closed interval 2 to 3. For each x in closed interval 2 to 3, the cross-sectional circle has radius, so that's the radius. Radius is going to be the vertical distance from the curve to the x-axis, that distance. But that's what we call y-coordinate of a point on the curve. Y-coordinate is square root x minus 1. So the radius is the y-coordinate, which is square root x minus 1. So the volume of each thin cylinder here is, that's the width and that's the cross-sectional area, pi y squared. Pi y is square root x minus 1 squared. That is pi times parenthesis x minus 1 delta x. So what is the volume of the entire solid? You are taking integral 2 to 3 integral cross-sectional area times dx, okay, dx with respect to x. So pi is a constant, we place it out, integral 2 to 3 x minus 1 dx. When I take integral of x, I get x squared by 2. Integral of 1, I get x. I need to evaluate these at the limits 3 and 2 and find their difference. So the first one gets me 9 by 2 minus 3 minus, with the lower limit I get 4 by 2 minus 2. When I simplify all of this, this fetches me 9 by 2 minus 3 minus 2 and a plus 2. That goes to 0 and I'm left with 9 halves minus 3, that is 3 halves. Pi times 3 over 2 cube units. Pi times 3 by 2. All right. Next problem will continue in our next video. Until then, bye.